Hi everybody, Miss Lorenz here. I'm going to go over lesson 12, the 5 problems that you did for practice. So bear with me here as I get my pen ready to go. I'm going to use something, how about pink? Let's do that. All right, so here's a sketch of a rectangular prism that's built from 12 cubes. And then we're first asked, how many faces does it have? Well, every rectangular prism has 6 faces. And then we're asked to find the surface area. So you'll see that I found the surface area showing my work here. So I can see I have 2 faces that are 2 by 2. And so this is a 2 by 2 face, and I know that the top and the bottom faces match, so there are 2 of them. I know there are 2 faces that are 2 by 3, because this one and then the one that would be opposite that on the other side of the rectangular prism. And then also these are 2 by 3. So I could have said 4 2 by 3s, but I separated it out just so that you could see where I was going with that. So I've accounted for all 6 faces here. If I do that multiplication here, 2 faces that are each 2 by 2 gives me 8 for my areas of my top and bottom. 2 faces that are 2 by 3 give me an area of 12, and so together that's 24. So I've got 2 12s and an 8, and that gives me a total of 32 square units. So that's really important that you make sure that you are labeling that correctly with square units. Surface area is always measured in square units. All right, I hope you like this isometric dot paper. Super fun for drawing. And here you had to draw a rectangular prism of some other kind and color each face a different color. You can see that I'm not very good at drawing straight lines, but I did my best here. Yours, of course, could be different, so have at it. Let's just go on to number 2. What's the surface area of this rectangular prism? So I did something very similar as what I did up here. And so you'll see that I am accounting for 2 faces that are 2 by 4. These faces right here. So I know it's the front side, and then the back side's going to match, even though we can't see it. I'm also accounting for 2 faces that are 2 by 4 up here. So once again, I could have said 4 faces that are 2 by 4, but I wanted to separate it out so we can see a total of 6 faces really easily, thinking of it as 3 pairs of faces. The last set of faces right here, there are 2 of them that are 4 by 4. And if we add up 16, 16, and 32, I think of it this way, you guys. 16 is 2 8s. So I've got 2 8s here, 2 8s here, and 4 8s here. So I have a total of 8 8s, and I know that 8 8s is the same as 64 square units. All right, we had to draw an example of each of the following triangles. So here I have a right triangle. I've even noted the right angle right here with an area of 6 square units. So I was just thinking of, like, what would the parallelogram look like? Well, it would be, you know, like this, and then it would be half of that because the triangle takes up half of the area of the parallelogram that share the same base and height. Same with an acute triangle. So like I know my lines aren't straight here, but I wanted each of these angles to be an acute angle or less than 90 degrees. So you can see that here in the green triangle. I used 2 as my base, and my height is 6. And so that would be 12 if it was a parallelogram, and so half of that would be 6. And then likewise with the obtuse. So I made this greater than 90 degrees to give me a lovely obtuse triangle. You can see that I'm using 3 as my base, and my height here is 4. So the parallelogram would have an area of 12, and so half of that would be 6. All right, so here we're finding the area of the triangle that's blue, and to show our reasoning. So you can see that I started by finding the area of the entire rectangle, 6 times 10. So I know the whole rectangle, RMNP is, and so from like this whole rectangle is what I'm talking about, is 60. Because it's a 6 by 10 rectangle. And then what I'm going to do is I'm going to subtract out each of these areas. So I'm subtracting out this triangle, which I found to be 18 in area, subtracting out this triangle, which I found to be 5 in area, and this triangle, which I found to be 20 in area. So if I add 20 and 18 and 5, I get 43, and if I subtract 43 from 60, I'm left with 17 square units. All right, and the last one, you'll notice we like to do these problems. Finding the area of this shape should be kind of fun. Again, I surrounded the entire shape with a rectangle. It's a 5 by 10 rectangle, so it starts out as at 50. And now I'm going to take this, this right triangle over here, and I'm essentially going to like combine it with this one to make an entire square that's 5 by 5. So I'm going to subtract out these areas from the rectangle. So I'm going to subtract out a 5 by 5, which is 25. And then I'm also going to subtract out these two rectangles, which again, or triangles, which again, if I put them together, they make a lovely 5 by 2 rectangle. So I'm really subtracting a total of 35 square units. And when I subtract 35 square units from 50 square units, I'm left with 15 square units. All right, and that's that for lesson 12. Hope that helped, everybody. Thanks for watching.